Hello everyone, it's coming up time to do these clock updates. So let's update, we'll synchronize our computer clock to the time server. Okay, so on the left here you can actually see there's another clock here, and this is actually because I'm running a virtual machine inside a inside a Linux machine, a Linux host. And that clock, the clock on the left here, actually does stay in sync by itself, but I'm not able to manually sync it for some reason. Okay, I'm not sure if you will notice the strange phenomenon here, but these two clocks are normally within half a second of each other. And I'm not sure what will happen, but it's been playing up most of today, and this clock here will start to race ahead, and it's to do with this, the time code protocol, or that's, what are you naming that wrong, but there's a system by which it does the synchronization, and it doesn't actually happen instantly. The synchronization occurs apparently over several minutes, it would seem, and this thing will race ahead, and it's actually, in times I've seen this thing 30 seconds ahead and then drop back 10 seconds behind. But it could be something to do with my my internet connection. I've been having big trouble with uploading videos. I think it's all related to this, the clock slowdown, everything. So should have turned the light on, you can't see anything on my watch. Anyway, I did this measurement about half an hour ago, so I know roughly what it's going to be. This is as it was about half an hour ago, and I'll redo it again just to check this and confirm it, because as I say, the times haven't been so stable. Yeah, the slowdown is slowed, so it's still decreasing, and the biggest slowdown would appear to have been, well, the previous, before the last 12 hours, so the 24 hours before the last 12 hours was actually the biggest slowdown. And that was when this strange thing was happening with my wireless button switching on by itself every 5 minutes, it seemed. Okay, so we lost, in the morning we lost actually 4.5 seconds. What's this? 4 seconds. This thing gained 4 seconds from here to here. That's the cube clock, which means it should have gained actually 8.5 seconds on average. So it's basically lost 4.5 seconds. But if you look at that over the last 12 hours, it's only gained 3 seconds. If you look at the charts, you can see the slight bottoming out happening. So, okay, that's the situation with the clocks. And okay, so the light's on. You can see we're not that far behind. Oh, okay, it's back. Okay, now it's caught it back up again. So it's really difficult to synchronize this. I'll do it again because it's, okay, these are 3 seconds out of sync, so there's something obviously wrong there. So we'll try this all again. And okay, what I suspect is going on is, well, I've noticed a few things, and I'll add it on to the end of this video, but what I think is going on is the Earth and Moon have lined up with the comet's tail, as in parallel lines compared to the comet tail. And it's, okay, this is just a idea, so I was thinking out loud here. An induction has occurred. We've got a comet tail which is, what is it, supposed to be 50 million miles long or something, which we can't see, but then again we're only looking at with optical telescopes at this, and perhaps if you're pointing a ultraviolet or X-ray telescope at it, you'd actually see the comet tail. Anyway, it's supposed to be 50 million miles long, so, well, that's a rather long wire, perhaps, well, essentially like a charge carrying, you know, a ray or whatever coming out from the sun, essentially perpendicular to the sun. And the Earth and Moon were in that alignment. We've actually moved slightly past that alignment, so this might be why the slowdown on the clocks is slowed. We're still slowing, but not as much as before. So it appeared to coincide with the slowdown on the clocks. So I think what's possibly happened is because they're parallel to each other, a long way apart of course, it's induced energy across the system from this comet tail, the sun comet tail, as if it's like a copper wire, if you imagine, inducing energy into the Earth-Moon system, and then maybe there's some connection between Earth and Moon beyond just a gravity lock. Okay, I'm going to stop this video here, and I'm going to explain this idea in greater detail. Okay, what we're going to look at now is in what direction was the Earth-Moon alignment at the times of these dips and some of these peaks. Now I've got Celestia here, and because we're 7 hours ahead of UTC time, and I've got this set to UTC time, we're going to take off 7 hours, and we're going to also take off another 12 hours because I'm actually taking a reading at the end of a 24-hour period. So we really want to know what it was approximately in the middle of that 24-hour period. So, okay, the first one we're looking at is going to be on July 3rd as a minimum, so there'll be July 2nd. So let's have a look at July 2nd. So let's set the time, July 2nd. Okay, this is the position of the moon. Let's see where it was pointing. And it appears to be pointing to Mercury. Okay, so I wasn't expecting that. I've already seen this before, this earlier today, but when I first saw that, I wasn't really anticipating that might be the case. Okay, so let's have a look at another one. Another dip actually happened on July 8th, so we look at July 7th. Okay, and we're pointing where? Well, it kind of looks like, zoom in a bit, looks, well, we're not pointing at ELenin. We look like we sort of halfway between ELenin and Saturn actually. There was a minor dip, but anyway, is there anything else on the other side of it that might line up? There doesn't really seem to be anything out there, so we're sort of in this way, between ELenin and Saturn. There's a minor dip. Okay. And the next thing we're going to look at is this peak up here, which seems to occur on July 14. So we look at July 13 on Celestia. And what are we looking at here? Okay, this is actually this direction towards Orion. And I've got this orientated with Orion at 12 o'clock because I always like to keep it there so I know where roughly it is. So Orion's at 12 o'clock, so that is actually pointing in the direction of Orion. That's interesting. That was the peak. And another dip and occurred, the bottom of the dip was on August 1st, so let's look at July 31st. July 31st. Okay, where are we pointing there? And that looks like we're pointing at the Sun. Or Mercury. Mercury. It looks to me like Mercury. Okay, so that's interesting. And we had another dip on August 9, so let's look at August 8. Oops. Okay, and well, I'd guess that would actually go into the Pleiades direction, but maybe it's up to Jupiter. No, it's too far around for Jupiter. So that's that Pleiades alignment. I can check that. I'll quickly scoot down and let's have a look which way we're going to go. This way. Okay, let's go a bit closer to the Earth and move around a bit. This way. Whoops. It's looking very much like it, isn't it? It's a little bit off from the Pleiades, and it's very hard to zoom, line this up properly, but it looks like it's slightly to the left of the Pleiades, but it's very close to it. Okay, so that's interesting. August 8th, so the cube clock, it was indicating a dip. Actually, you can't see it on the screen, I'll move it across a bit. On August 11, so let's look at August 10, and that would be the Orion alignment again, I believe. In fact, we can just leave it like this for the moment. August 10. So let's zoom around. There you go. This Orion alignment. Wish I could get it more sensitive than that. But anyway, basically it's the Orion alignment. It's very hard to zoom in on the exact spot. If I zoom in, maybe I can get it more exact. Okay, that might look better. Let's zoom out a bit. Oh, we still overshot the mark. But anyway, this is the position to the left of Orion. If you zoom, you can't see Orion here. I'll pull it up. There's Orion's belt. And this is the alignment where we seem to find these sorts of things happening along here. And that's, I think it's around about here is this blacked out area in Google Sky. So this is a very important alignment, of course, and this is the alignment that's coming up in about 6 hours from where we are right now, in real time, that is. So, okay, we had a peak. Look at this peak. This peak occurred. Oops, you can't see it. I'm going to pull it across over that. Okay, this peak occurred August 22nd. So let's look at August 21st. And I might have to go for a top-down view for this. Okay, and I bet that's the alignment to Jupiter. Let's see if I can zoom it in. Oh no, this is the Pleiades. Left of the Pleiades. Okay. So that was when it peaked, just before we got to the Pleiades alignment. And then we had the big drop. Okay, and this is what's interesting. What was the trigger for the drop? Well, I suspect, I'll go down to back to a top-down view. Going the right way for a top-down view. I have to zoom out a bit. I might have to back to front. Okay, everything's in the right spot. Okay, so this must be the right way for a top-down view. If you look at the alignment for the Moon and Earth, it's a very close match to the direction of ELenin's tail. We zoom into ELenin. Tell it to follow ELenin. Okay. We zoom into ELenin, that's the direction of the tail. And we've been in that alignment for the last 2 days. We're actually getting out of that alignment. For the last 2 days during this big drop in clock speeds, this has been the alignment. So I suspect that it's ELenin working as some sort of inductor, and it's okay to induct between current or energy between two conducting wires, for example. You need an alternating current. Well, you don't necessarily have to have an alternating current. You can also have a pulsed current. So if this is energy going at a certain frequency, it's not necessarily a DC current we're looking at. We could be looking at something that's radiating energy at a high frequency, and that perhaps is being picked up by the Earth and Moon alignment, which is acting like it with the Earth and the Moon acting like an antenna. So let's look at what it is today. Okay, we're just getting past the alignment. Okay, so we're a little bit, the Earth-Moon alignment is a little bit, if you draw a ray between the Earth and Moon, it's actually a little bit past the ELenin alignment here. You can see ELenin here pointing in the same direction, but we're a little bit past that point. Okay, so I don't know if this is what actually has happened, but this is a theory I'm going on at the moment, or my current thoughts on the topic. And if we tip ourselves over, you can see what's coming up. Zoom in a bit. Okay, we'll go to the Moon and you'll see what I'm talking about. See, we're coming up to this Orion alignment. Oh, the Moon disappeared. Sorry about that. I think I'm missing some images in my Celestia program. Okay, we should be able to see the Moon now. Okay, so if we're looking at the Moon from the Earth, as you can see at this point in time, and we're at real time, set time to current time, we're getting very close to this actual alignment where a lot of major earthquakes occur. And this is because the Moon coming into alignment with whatever this object is to the left of Orion, and I suspect it's down here somewhere. Well, the alignments between the Earth and Moon and that kind of alignment triggers big earthquakes. And we just had this massive or bizarre energy event where the clocks have slowed down. I assume we've been charging up with energy. We had earthquakes popping off in strange places like Virginia and places where they don't normally occur so often. I think it was in Washington, sorry. Yeah, so where's this earthquake going to occur? Well, exactly when? Okay, I'm not an earthquake. Well, I don't want to get into the earthquake prediction, but okay. Let's speed it up and I'll show you where these things tend to occur. Just past this point, and it's really about this line here, somewhere about there. And if we look back at the Earth, okay, this is what you're looking at. At the moment of the earthquake, it's probably the moon's going to be over the Pacific, which means it's probably or possibly an earthquake on the Ring of Fire. Basically, it could be anywhere around here, from New Zealand, Indonesia, up to Japan, Alaska, west coast of the United States, but probably, or Chile, which is just passed over the horizon. But we know that the Northern Pacific moves mainly with this Orion connection. I mean, it just completely dominates the sea levels in the Northern Pacific, or the sea level readings that we get from the Northern Pacific. So I would pick the Northern Pacific, and I would pick Japan as a likely candidate. Hopefully not, but quite often these earthquakes actually do occur in the middle of the sea, and quite often they don't even get reported, and you'll only see it in the sea levels themselves. So if nothing's reported, I'll check through the sea level data and see if there was any anomalous big movements in sea levels in the Pacific over the next 12 hours. So I'd expect that in about, well, UTC time, here we go, somewhere around 6-7 p.m. UTC would be a likely time for a major earthquake, but hopefully away from any populated areas. Okay, thank you for watching.